All right, so for a problem like this, what we got to do is we got to determine where this problem is, right? Remember, sine is going to represent our, y over our x. So right now I'm looking at this as far as like on our unit circle. This this value is going to be off of our unit circle. Therefore, our angle, it's going to be a little bit more difficult for us to be able to figure out. It's not going to be something where we can say it's going to be a unit circle. One thing I can represent, sine is y over x. Sine is going to be your y over your hypotenuse. Therefore, my hypotenuse is going to be 5, all right? And I notice that since my y, or my y is negative, I have two triangles I can theoretically make. I could have this being -4, 5, or here being -4, 5. So I have two triangles I can use. Remember, we can't use the unit circle on this because the unit circle has a hypotenuse of 1, right? So what I'm going to do is I need to first determine what my constraints are going to tell me which triangle to pick. So I look at my constraints, and my constraint says the angle has to be between pi and 3 pi over 2. Well, just to go back and again reflect on the unit circle, if here's pi, here would be 3 pi over 2, here's pi over 2, here's 0 or 2 pi. So what you notice is if my angle has to be between pi and 3 pi over 2, that means my triangle has to be in the third quadrant. So therefore, here's the triangle we're going to deal with. All right. Now the next thing we need to do is determine, that's the find sine. They want us to find, I apologize, I didn't write up the thing. It says find the sine of 2u. And I put a dot there for some reason. There you go. It just says my angle. What exactly does it say? Oh, yeah, okay. That does say the sine. So it says the sine of my angle u is -4 or 5. It says find the sine of 2u. So remember, when using my formulas, I look for the sine of 2u. The double angle formula for sine is equal to 2 sine of u times cosine of u. Now, here I have the opposite and the hypotenuse, but I do not have the adjacent side. So I'm going to have to use Pythagoras' theorem to figure out the adjacent side. Remember, Pythagoras' theorem says your leg plus your other leg equals your hypotenuse squared. Well, here's my right triangle. Here's my leg, here's my other leg, so I have a -4 squared plus b squared equals 5 squared. Fortunately, I know this is going to be a Pythagorean triple, so therefore this is going to be, b is going to equal 3. Now the important thing to understand is this is also going to be a -3 because look at, we're in the third quadrant. Going to the left is going to produce a -3. And you also can, recognize that if you're going to take your b squared, we obviously notice that you could do the plus or minus. We're going to be using the negative value of this. So, right now b is going to be equal your plus or minus, I guess, square root, plus or minus 3, but we're going to use the negative value of that. So now I can determine that I know sine of u is -4 over 5, so therefore cosine of u is now equal to -3 over 5. So to solve for our double angle, all I simply need to do is plug in the values. 2 sine of u is -4 over 5. Cosine of u is -3 over 5. So now all I simply need to do is just multiply across. -4 times -3 is going to be a positive 12 times 2 is 24 over 25. And there you go.